welcome back. This is our second lesson for the week. It is 2.3. We better get started because this is a big one. All right, so as you can see, still doing solving systems of equations. So we're still going to be solving, and a solution for a system of equations is always a point. So our answers are still going to be points. That has not changed. Remember, systems of equations means two equations, and the word equations actually means a line for us. So we're still finding where two lines cross, but we're using substitution, which is different than last week. So we're not doing it graphically, which is visually. We are doing it with substitution, which means using algebra. All right, so let's take a look at some examples using money again, which is a really good way to kind of give you an idea of the big idea behind this so that maybe it makes more sense when we get into the actual algebra. So again, if we look at something that we saw last lesson, we can say that $1 is equal to 2 quarters, right? That's 50 cents. And then 10 nickels. So 10 nickels is also 50 cents. So 50 cents and 50 cents, that's the same as a buck. That's $1. All right, so let's say we have $13. We have a $10 bill plus 3 $1 bills. All right, so that's equal to $13. So what we could do is that, okay, had a glitch there, but okay, as I was saying, what we could do is just like we did in the previous lesson, we could take each one of these bucks, each one of these dollar bills, and we could replace it with a stack of coins, 2 stacks of coins. So this next image down below, it's still $10 here. But instead of having 3 $1 bills, we now have 3 stacks of coins that we know are equal to $1. So it's 3 times $1, but instead of having $1 bill, we are going to have a stack of 50 cents and another stack of 50 cents. All right, and that's still equal to $13. We just have coins instead of dollar bills. So why am I going on about dollar bills and coins and all this? Well, it's a really good metaphor for the next type of substitution that we're going to learn about. So let's get into it. How does what I just said relate to what I'm going to say? If you look at this system of equations, remember, solve the system of equations. We start immediately by drawing a fill in the blank at the end so we don't forget our final answer needs to be X and Y. So this is like saying here, a $1 bill, let's get smaller here, a $1 bill could be equal to, a 50-cent stack and a 50-cent stack. Now down below, we have maybe what would be, that this is representative of the $10 bill, and then let's say here this would be representative of the 3 $1 bills. However, we know that each one of the dollar bills could be replaced by the stack of 2 stacks of 50 cents. And okay, so let's break it down a little bit more. Essentially what we're saying is that since this is a y and this is a y, if y is equal to x minus 6, I can take that chunk, take that little piece of an equation and put it inside the other equation. So you look for the variable that's alone, which is the y. And I'm going to kind of erase all this and show you the strategy that I use. Find the variable that's alone on one side of the equal sign. That's this y. Find that same variable in the other equation. That's that y. Now we're going to replace this y with the other y. So start rewriting the second equation. Stop when you get to your highlighted number or letter. Look back up the other equation. The other equation is equal to x minus 6. Same idea as 2 stacks of 50 cents. And we're going to replace the y, by y, with the x minus 6. And then we're going to keep writing until we get to the end of the equal sign, or to the equation. So here is this. Here is this. And here is this. All right, so what do we do now? How do we take this big, long, confusing thing and solve it? Well, we did learn how to do equations like this at the beginning of the school year. If I'm going to do this first one really, really slowly. If this is not enough explanation for you, that is okay. I respect and accept wherever you're at. Just means that you're going to need to come to the assignment session on Thursday at 2 p.m. or reach out to me and we can do some practice one-on-one or in a small group. All right, let's get started. So remember, whenever you see parentheses and you're trying to solve an equation, those gotta go first. So we're gonna multiply in through the parentheses. Distribute is another name for that. The 3x has not been changed, but the positive 5x gets multiplied by the 1x, giving us positive 5x. And I almost made the mistake that a lot of students make, which is they would say 6x because they add on accident. So the next thing we're going to do is we're going to multiply the positive 5 times the negative 6. Make sure that you understand that any number that is to the left, or the symbol that is to the left of a number belongs to that number. So that negative belongs to that 6. You can't just multiply by the 6, you multiply by the negative 6. Okay, now the next step here is we need to combine our like terms if they are on the same side of the equal sign. So remember, same side, add. 5x and 3x make 8x's. We're adding the two groups together. We didn't change anything about the group of negative 31s, and we didn't change anything about the group of 34 ones on the other side. And now it's just a two-step equation. All we're doing is just solving for x. So we're going to go plus 30 to both sides. We want to get the x alone. We created 0 on the left-hand side. 34 and 30 makes 64. The 8x's are still on the left-hand side of the equal sign. And the last step is to divide by the number that's in front of the x. Always dividing top to bottom. We're going to get x is equal to 8. 64 divided by 8 is 8. Okay, so that was a lot, but we're not done yet. We also need to get the y value to put here. We found the x, we need to get the y. And the whole reason why we set ourselves up the way we do is because it's very, very common that students forget to find the y. They're just so relieved to be done with finding the x that they forget to find the y. All right, so just like in the other question, you find the equation that has the y alone. And that means that we're just going to plug in the x value that we just found, which is 8, and subtract 6. So no need to solve at all. In your calculator, you could put in 8 minus 6, but I know that 8 minus 6 is 2, so I'm going to put 2 in for my y value. Whew. You know what? I'm jumping into the next question. Little less explaining, little more flow to it so we can get quicker and better and see another example. This next example is a great example for us to get into. First step, look for the variable that's alone on an equal sign, on the side of an equal sign. That's going to be this y here. It's on the bottom this time. That's okay. Find that same variable, that same letter in the other equation. Start writing that other equation out. So we have x minus 3. Stop when you get to the highlight. This is where you're substituting. Look at the other equation. You're going to replace that letter, that variable, with the other equation. And then you're going to keep on writing until you get to the end. So remember, this is the same as this. We substitute in the y, the equation for y, and then we have to keep writing, and we got equals 17. All right. So again, I'm going to pick up the pace a little bit. We're going to distribute. You got to get rid of those parentheses before you can solve. So distributing the -3, remember, anytime you have a number, the symbol to the left of that number belongs to it. So I don't want to catch any of you multiplying without the negative, because that negative is a part of that 3. So we have x minus, -3 times 2 is -6, and then you're multiplying by the x2. -3 times 6 is -18. And then we didn't do anything on the right-hand side of the equal sign, so we just write that there. Now, again, if you have two groups that are like terms on the same side of the equal sign, you need to combine them before you can continue to solve. So we have a group of 1x and a group of -6x's. Remember, this is -6x's. If you have a naked x, it has a secret 1 in front of it. So we're going to add these two together. 1 plus -6. 1 plus -6, feel free to do it on your calculator, is -5. We didn't do anything with this group of -18 ones, and we didn't do anything with this group of 17 ones on the other side of the equal sign. Again, now it's just a two-step equation. All we got to do is just create a 0 with the ones first. Always add or subtract the group of ones depending on if it's a positive or a negative. That creates a 0, so we're close to getting our x alone. 17 plus 18 is going to be 35. All right, and then we're going to divide by -5 on both sides. Divide by the number that's in front of the x, and we're going to get x equals -7. Okay, so a lot of people would stop there and be like, whew, I solved that, I'm done. But no, we know that our final answer needs to have a setup, fill in the blank, so we don't forget. We also have to find the y. So let's find that y. I'm going to circle this and move it off to the side a little bit. All right, so we want to take the equation where the variable is alone. In our case, it's y equals 2x plus 6. And we found the x. We found it was -7, so we're going to replace it in the equation. So we have y equals 2 times -7 plus 6. Remember, when two letters are next to each other, or a letter and a number are next to each other, it means multiply. And feel free to put this into your calculator and do it on your calculator. That's totally fine. But if we want to do it by hand, we get y is equal to -8. So I'm going to put -8 in there. And now I'm done because I have both parts of my point. All right, so you guys have an example to do here with question number 1. I'm going to start a new video. This video is going to have 2 parts because I'm going pretty slow through it. So watch the next video after you complete your example, and you'll see 2 more examples from me and the password. So see you in a minute in our second video for this.